This is question 13 on the extra practice paper review for the Unit 1 test. So when we write prime factorization, what we're going to do for this particular one is find the LCM. So we're going to prime factor both numbers, then we're going to look for the greatest amount of each prime that we see. So we're going to prime factor the 24 first. So 24, 2 goes into this 12 times, 2 goes into 12 6 times, and finally 2 goes into 6 3 times. So the prime factorization of 24 is 2 to the third times 3. Now we have to do 12. So 12 is 2 times 6, and 2 goes into 6 3 times. So 12 is 2 to the second times 3. Now if I want to find the least common multiple of those two, what I'm going to do is include the greatest amount of each prime that I see. So in both choices, I see a 2 and I see a 3. So the greatest power that 2 is raised to is out of the 24 choice. So I'm going to include 2 to the third times. Now, I also see a 3. I have 3 to the first in the 24 choice, and out of the 12, I have 3 to the first as well. So neither one is bigger than the other, so I'm just going to include 3 to the first. So the LCM for this question is going to be 2 to the third times 3, which equals 2 times 2 times 2. That's 2 to the third times 3. 2 to the third is 8. 8 times 3 equals 24. So 24 is going to be the greatest, or excuse me, the least common multiple of both 12 and 24. Okay, so let's go ahead and move on to number 14. Maxim is putting 553 cans of green beans and 790 cans of corn into boxes for a food pantry. He wants to distribute all of the food and assemble the most amount of boxes. How should this be done? In this case, we are actually looking for the greatest common factor. So I'm going to both prime factor both numbers, 553 and 790. And I'm going to give you guys a hint that 7 does go into 553 79 times. So I'm just going to check that really quick. So 7 times 79, make sure that equals 553, and it does. And then for this one, instead of doing 2 first, I'm going to make my life easy and do 10 times 79. 79's prime, 10 breaks up into 2 times 5. So 553 is 7 times 79, and 790 is 2 times 5 times 79. So when we find the greatest common factor, we're looking for primes that are the same in both. So the only thing that's the same in both is 79. So I know that I'm going to need 79 is common to both. So what I'm going to do is I'm going to take the green beans here, and I'm going to take the 553, and I'm going to divide by 79, which equals 7. So I need 7 cans of green beans in a box. And by the way, I'm going to have 79 boxes total. And then the corn, I'm going to do the same. I'm going to take 790 and I'm going to divide it by 79, which equals 10. So in those 79 boxes, they're going to put 7 cans of green beans and 10 cans of corn in each one. So again, I found the GCF because of the wording. So let's look at 15. I'm just going to pronounce this as Tully is buying chocolate chip cookies and snickerdoodles for a class reunion. Each package of chocolate chip cookies contains 10 chocolate chip cookies, and each package of snickerdoodles contains 12 snickerdoodles. What is the least number of each kind of cookie she must buy to have an equal number each? So least number and equal number gives me a clue that I have to find the least common multiple. Okay. So again, I'm going to prime factor both the chocolate chip cookies and the snickerdoodles. So chocolate chip comes in packs of 10. So 10 prime factors into 2 times 5. And snickerdoodles come in packs of 12. So 12 breaks down into 2 times 6. And 6 breaks into 2 times 3. So the chocolate chip cookies are 2 times 5. That's prime factorization of 10. And the snickerdoodles, the prime factorization of 12 equals 2 to the second power times 3. Okay, so again, for the least common multiple, we have to include the largest number of each prime that we see. So I see 2's in both, so I include the largest one, which is 2 to the second. I see a 3, and I'm going to include it, and I also see a 5. So least common multiple is going to be 2 times 2, which is 4, times 3 times 5. So I get 12 times 5, which is 60. So she has to buy 60 cookies of each one. So 60 of each kind of cookie. So it goes on to say, how much must she buy of the chocolate chips and how many packages of snickerdoodles does she need? Okay, so if I look at chocolate chips, I know I need 60 and they come in packs of 10. So 60 divided by 10 is 6. So I need 6 packages of chocolate chip cookies. And then for the snickerdoodles, same process. I take 60 that I need divided by, the pack comes in 12. So 60 divided by 12 is 5. So I need 5 packages of snickerdoodles. Okay, part B of this question says Luciana is planning a party. She has 35 candies and 30 toys to place in party favorite bags. Using all the candies and toys, no leftovers, what is the greatest number of identical party favorite bags she can make? Greatest number, again, we're looking for the greatest common factor, the GCF, or greatest common divisor. All right, so again, prime factor everybody out. So candies is 35, so this becomes 5 times 7. And toys is 30, so prime factorization of toys is 3 times 10. 10 breaks up into 2 times 5. So if I put these on top, candies is 5 times 7, and toys are equal to 2 times 3 times 5. And again, for the, and I accidentally said greatest common factor, guys. I meant to say least common multiple. Or no. I was right the first time. Sorry. Okay. So we're looking at something common to both. What's common to both is 5. So I know I'm going to have to make 5 favor bags. Okay. So now to figure out how much goes in each one, we do the candies first. So there's 35 candies that she has. If I'm making 5 favor bags, I divide that by 5 to get 7. So 7 candies need to be in each bag. And then for the toys, I know that she has 30 toys, and I'm making 5 favor bags. So 30 divided by 5 is 6. So 6 toys and 7 candies have to be in each bag, and there's 5 favor bags. Okay, so I'm going to put that information here, 5 party favor bags. There will be 7 candies and 6 toys in each bag. Okie dokie. Let's go ahead and move on to number 16 here. Write this number as a whole number or a decimal. So it's in scientific notation. Remember, if you have a negative exponent and you have to write this number as a whole number, you're going to move the decimal to the left because negative exponents make the number smaller. So 6.12, I'm going to move the decimal to the left 4 places. And the reason why I knew that is because my exponent is negative 4. So 1, 2, 3, 4. I'm going to have to plug in some zeros. So 0.000612 would be my decimal answer. All right, I'm going to do 17 as well. Write this number in scientific notation. Use an asterisk for the multiplication symbol. Remember, scientific notation is I have to have a value A. And remember that A has to be a value between 1 and 9. And I have to have it multiplied by 10 to some power. Okay, this is a large number. So I know when I do exponential notation that the exponent will be positive. Okay? All right. So first of all, I got to figure something out. I have to move the decimal so it's between the 1 and the 1. Because remember, that a value has to be a value between 1 and 9. So let's see how many spots I go over. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1.16 times 10 to the 8th power. Okay, that is questions 13 through 17. Thanks for watching.